Today's friend we will see the assignment of Mathematics BCA semester 2. First question is define the following terms: events, mutually exclusive event, classical probability, independent events. Also prove the following terms. Now let us see one by one. First is the definition of events. The result of experiment are known as events. A probability event can be defined as a set of outcomes of an experiment. In other words, an event is probability is the subset of the respective sample space. Example: if a coin is tossed, head and tail are two different events, and then next 1, 2, 3, 4 and 5, 6 are different events when a die is thrown. If A is an event and S is a sample space, then A is subset of sample space S, that is ACS. Generally, events are denoted by A, B, C or A1, A2, A3, etc. If A equals to null, then A is impossible event, and if A equals to S, then the event A is occur. Second event is a mutually exclusive event. Now we can see the diagram. In probability theory, two events are said to be mutually exclusive if they cannot occur at the same time or simultaneously. In other words, mutually exclusive events are called disjoint event. If two events are considered disjoint event, then the probability of both events occurring at the same time will be zero. That is, if A and B are two mutually exclusive events, then A intersection B equals to null. Next point, head and tail are mutually exclusive event when a coin is tossed. Now let us see third definition, classical probability. If an experiment can result in an exhaustive, mutually exclusive and equally likely ways, and if m of them are favorable to the happening of an event A, then the probability of happening of an event A is defined as the ratio of n to n. The probability of happening of an event A is denoted by P of A. P of A equals to favorable cases for happening an event A, and then divide by total exhaustive, mutually exclusive and equally likely cases. So P of A equals to m divided by n. And next definition is independent events. Events are said to be independent if the happening of one event does not depend upon the happening or non-happening of other events. Example: when a coin is tossed two times, the event of getting head in the first throw and that of getting head in the second throw are independent events. Here, the result of second throw does not depend upon the result of the first throw. Then we can see the proof. P of A union B equals to P of A plus P of B minus P of A intersection B. Now see the proof. Then prove the second term. P of A union B equals to P of A plus P of B. Now see the proof. Now let us see a second question. What is the meaning of random experiment, trial, an event, equality likely event, mutually exclusive event, and an independent event? Mutually exclusive event and an independent event, we can see the first question. Now there is answer is first, random experiment. An experiment which can result in any one of the several possible outcomes is called a random experiment or trial. Example: tossing of a coin is a random experiment. Second, drawing a card from a pack of playing cards in a random experiment. Third, throwing a die is a random experiment. Next, equality likely events. Events are said to be equally likely if we have no reason to believe that one event is preferable to the others. Head and tail are equally likely events in tossing a coin. Equally likely means that each outcome of an experiment occur with equal probability. And then other two topics, mutually exclusive event and an independent event, we can see the question number 1. Now we can see the question number 3. Explain normal distribution and list out property of binomial, Poisson and normal distribution. Normal distribution. There are many distributions of continuous, but the most important of them is normal distribution. Normal distribution has a wide application in statistics. This distribution was first given by de Moivre in 1773. Gauss and Laplace also derived the mathematics of this distribution from the study of distribution of errors. The graph of normal distribution, called normal curve, is bell-shaped and its extends identically on both the sides of x-axis, but does not mean it, that is, the behavior of the tails of the curve is asymptotic to x-axis. If a continuous random variable x obeys the following probability law, it is said to be normally distributed. Then we can see the formula of this normal distribution. Here mu and sigma are mean and standard deviation of the distribution, and they are called the parameters of the distribution. E and pi are numerical constant and their approximate value are 2.7186 and 22 divided by 7 respectively. Area under the normal curve. We show that the probability density function of the normal variable is mu and sigma are the parameters of the distribution. This curve is known as normal curve. A normal curve is symmetrical on both the sides of the central line. The area between the normal curve and x-axis is taken 1, and also the total probability of a variable x taking value between minus infinite and plus infinite is 1. So total area is 1. And then we can see the example of normal distribution, and then we can see the property of binomial distribution. And first one is this is a distribution of discrete variable. Second, NP are the parameter of binomial distribution. The mean of binomial distribution is NP, which show the average of number of success. Fourth topic is the variance of binomial distribution is NPQ, that is SD equals to root my NPQ. 5 is P equals to Q equals to 1 divided by 2. When P less than 1 divided by 2, its skewness positive, and when P greater than 1 upon 2, its skewness negative. The variance of binomial distribution is always less than its mean. Property of Poisson distribution, we can see the page, and then we can see the normal distribution property. Normal distribution property is given by this page one by one. You can see this page and write this your notebook.